Yes, good morning. Am I audible?
Yes, sir.
Okay.
Good morning, sir.
Yes, sir.
Yeah, good morning. Uh, so, yesterday we finished understanding how to delete from the front end of the circular singly linked list and rear end of the circular singly linked list, and then we also understood how to display the content of the circular singly linked list. Okay. So now the program number 8. Okay. I hope all of you know this doubly linked list because we have already finished discussing it, and the lab program on the same. Yesterday I just showed you this question. Okay. Just copy this question, program number 8. Okay. The complete question you copy. So now we'll just go through this program because you should not find any difficulty in understanding this program, since we have worked on all the functions. Okay. Inserting at the front, deleting from the rear, inserting from the middle, and deleting from the middle. Every possible cases we have already discussed the functions, and this should not be the program should not be a problem for you. Okay. You have to understand this easily. Okay. Okay, so now as it was already told in the yesterday's class, the various data fields that are used in this program are social security number, name of the employee, department of the employee, designation of the employee, salary, phone number. Okay, so these many data fields will be having, and in addition to this, there will be two more links. One is the left link, another one is the right link. Okay, and then these are all the operations that we need to do. Okay, so now okay, these are the header files because malloc is also used because we go for allocating the memory dynamically, and then so we have. Okay, so here define the max size as 30. Okay, this is for all the arrays that we use. So for example, name you have to read, you have to make it as a character array. Department you have to read, you have to make it as a character array. Designation again a character array. Phone number also we are reading it in the form of character array. So social security number we are making it as SSN integer, and then the salary we are making it as float. Okay, so all everything, all the data field and the link fields, we have written them inside the structure, and the name given to the structure is a list. So if you want, you can call it as a doubly linked list, but we are calling it as a list here. Okay, and yeah, and these two, if you observe, they are the self-reference self-reference pointers there. So struct list start previous. So this name of the structure itself is struct list. Now when I say struct list start previous, this is a pointer to this structure itself. And similarly I have next. Now instead of taking it as left link and right link, so we have taken it as previous and next. So previous is nothing but the left link, and next is nothing but the right link. Okay, don't confuse with the names, because when we were discussing the theory part of this, and all the functions that we understood by writing it as left link and right link. So it is just a name, but ultimately the understanding is important. So previous here is nothing but the left link, and the next here is nothing but the right link. Next, and this function you are already familiar with because we use the same type of macro even in the singly linked list program also to allocate the memory dynamically. So this is the macro, and even I told you the difference between the procedure or the function and the macro. So macros are the inline substitution, which are much faster than compared to the function call. But the disadvantage of the macros is that they make the program length increase. Okay, but functions or the procedures, the program length is not going to increase, but so they are a little bit slow than compared to calling the macros. Now yeah, these are the parameters which you are passing to this macro p, s and t. S represents the total number of bytes, or the total bytes of memory to be allocated, and T is the pointer to this. Okay, and I'm casting T is of this type, this type of this struct list. So I'm casting it, and P is the pointer which points to the newly created node. If P is equal to null, we say it is an insufficient memory. And then we are declaring the prototypes for various functions. And then before that, say I want to declare, whenever I want to declare a pointer to this struct list, instead of saying struct list star some pointer name, now I just want to make my job easy. What I'm doing is, so I'm creating a type definition for my struct list. So type def struct list star node I'm writing here. Now henceforth, if I want to declare a pointer to the structure list, so I can simply do it by saying node and node space some pointer name star pr star xr star yr star z, something like that. I can go for declaring a pointer easily to my structure henceforth. And now I'm writing the prototypes of all the functions. So first I'm writing it as create, and so I'm passing the node. So one argument what it is taking is the node itself, the node of the doubly linked list, and we are passing the integer also. Okay, and then the return value from the create is the node again. So when we go to the function definition, we will understand all these things much clear. And then insert front, again we are passing the node, and the return value from insert front is also of type node, nothing but, so node is nothing but what right now, it's a pointer to this struct list. And then insert rear, delete front, delete rear. So these are the functions, and in addition to that we also have display, because any point of time you should go for displaying the content of the doubly linked list. And then read data also. So read data. Now int ssn, okay, so character name max, so this is for for storing the employee ID, or else you can also call it a social security number. And then employee name, department, so designation, so for float, salary is of type float, and then the phone number character array, and then int main, we are starting from here. So people understood till here?
Yes, sir.
Okay. So observe now. So this goes similar to the singly linked list what you have already understood. So in choice and done, and then node fi. I hope you people remember, even in the singly linked list we did it the same. Say I want to declare one more pointer with the name fi to struct list. How to do it? Node fi. Simple. Since I have already made node star node as the type definition for struct list. So sir, I don't want to do it like this, sir, I want to use struct list itself. How to do it? So you can do like this, struct list star fi. Okay, so you can do it like this, or else, so you can, and which one is easy now? So you don't have to write this much, so just write node and fi, that is done. OP people understood? So this node fi right now is exactly same as struct list star fi. Is that clear?
Yes, sir.
Okay.
Yes, sir.
Now and then the number of employees, I'm storing it into n. Okay, so in create, so we were passing an integer argument, no? So node we were passing, and then int we were passing. What is this int? Is the number of employees. So the number of employees to be created. Okay, so that is n, int n. And then initially, since you are creating the list for the first time, doubly linked list for the first time, so fi should be initialized to null. Even we did the same even in the singly linked list also. Okay, and then done is equal to 0. This you know, so because we are using this even starting from the first program. So initially we make done is equal to 0, while not of done, not of 0 is 1. the condition is true, it comes into the while loop, and it will go for displaying the menu options. Now 1 for creating, 2 for insert front, 3 for insert rear, 4 for delete front, and 5 for delete rear, so display, and 7 is for exit. So totally 7 options are here. Okay, and then read the choice. So choice, we are reading it to the variable choice, it's an integer variable, and then switch choice. Say for example, I have taken the choice as 1, so I come to case 1, and then immediately in the case 1 I am reading the number of employees, and to read the number of employees I have already created an integer variable n. Okay, I am reading the number of employees to the variable n. I am storing it into the memory location n. Now after that, what we are doing, we are calling create by passing fi and the number of employees to be created, and fi it's a pointer to the struct list, but initially it is initialized to null. See, when I am explaining, you got to observe my mouse pointer also. Okay, so we are initializing fi to null. Now this is create, what we are calling. So now create is exactly same as the create function that we understood in the singly linked list. Okay, now we'll go to the create function. See, create. Now node fi, first I am writing. So in the main program I had just written it as fi, meaning first. Now when it comes to the formal argument, so I am taking it as first. Okay, and then the number of employees, it gets copied to the number of employee nodes to be created, gets copied to n again. Now here, so I have taken an integer variable I for the looping purpose, and node q. So what is this q now? It is one more pointer to the struct list. So q acts as one more pointer to the struct list, and now I am checking if first is equal to null. What does it mean? If first is null, so the list is empty. Okay, there is no list existing. Okay, now the list has to be created all the way from the beginning. If first is not null, so I just say the list already has some student data. Okay, the list already exists and it has some student data. This is what I say. So using the option 1, so I can go for creating the new list of employees only if the first is null. Okay, if first is null and I don't have any list of employees, then I come here for I is equal to 1, I less than, and I plus plus. Okay, how many times I want these statements to be executed? So for n number of times, where n is the number of employees required. Okay, so many nodes I need to create. Now what I do, enter employee data 1, enter the first employee data. This is what the message I print on the screen, and then immediately after that I make a call to read data, and this function is exactly same as the singly linked list, what we understood, but exactly same in the sense all these things are same as the singly linked list. But when I say insert front, so you're going to deal with the 2 pointers here, but there in singly linked list we dealt with only 1 pointer, because there was only 1 pointer, it was the next field, but here you have the previous and the next field. Hope you people are following.
Yes, sir.
Okay, now we need to go to the read data. One second. So now we'll go to the function read data. Read data, I think it was here only. Now read data, you go for reading the this is student, sorry, it is not student. Enter employee employee SSN, and then employee name, employee department. So you're reading it. So to SSN, and name you're reading it to name, and department you're reading it to department, and designation to DESIG, salary to this, and phone number to this. So read all the data. After reading all the data, so you got to call insert front. When you're calling insert front, now what is the pointer you're passing? First, and first is already null. Okay. Now insert front, you already know it, how to do at the insert front for a doubly linked list, because I've already explained that to you people. Okay. Now we will check how insert front is done. Okay. Have a look. See now insert front. So node first is passed. I've taken another pointer Q. Now before inserting, so first I need to create the node. Okay. How do I create the node? The memory required memory for the node should be allocated. I'm calling malloc, and Q I'm passing. Size of struct list. What is the memory that should be allocated? The memory that should be allocated for a node is size of struct list. And struct list I've already shown you. So struct list has these many members. These many members it has. Okay. So this is an integer. So here, so if I assume size of the integer is 2 bytes, so 2 bytes for this, and since max is declared as 30 bytes here, 2 plus 30, 32, and 30 more bytes, so 62 bytes plus 30 more, 62 plus 30, 92 bytes, and float if 4 bytes. Okay. 92 plus 4, 96, and this is again 30, 96 plus 30, it is 126 bytes, and for this again integers. Okay. 126 and 2 bytes, 130, total 130 bytes of memory should be allocated. Okay. Now what it is doing now, size of struct list, so it's passing. Size of this is total one, we computed just now 130 I think. So 130 bytes of memory should be allocated. So now the macro is called, let me go to the macro here, and P is just pointing to the same node to which Q is pointing, and S is now 130, and T is of type node. Okay. So many bytes of memory it will allocate, and who will be pointing to that? P is pointing to that. Okay. So P is pointing to that. Okay. So P is pointing to that there, but here this is the actual argument. The formal argument was P. Now P and Q, they are pointing to the same thing now. Okay. Now next, after the node is created, so a node something like this. Okay. Insert a table. I need now 1, 2, 3, 4, 5, 6 plus 2, 8 columns I need, and 1 row is enough. Okay. Okay. Now observe. So this is your previous field, and this is your next field, and here I need to store the social security number, Q arrow, and who is pointing to this entire node now? This is one single node with total 8 fields. Okay, and 6 fields are for storing the actual data, and this is the previous field which stores the address, and this is the next field which stores the address again. So Q arrow SSN, here I am storing the social security number of the employee, and then to Q arrow name, the next field I am storing the name of the employee, and in this field I am storing the name of the department of the employee. Here I am storing the designation of the employee, and then Q arrow salary, here the salary goes, and the phone number goes to this field. Okay, and now observe now. So since this is the first node which I am creating, okay, so q arrow previous is equal to null. Now what we are doing here, we're not making use of the concept of what header node, but when I explained using the concept of the header node. So we're not making use of the header node now. So since this is the first node and there is no other node present here towards the left side of this node, so the previous field of this node should be made as null. So previous q arrow previous is equal to null. So this field we are making it as null. Okay, so SSN goes here. Let me write SSN comes here, and then the name of the employee here, and then department here, department, and then designation here, and then salary, phone. And here what we are doing, null we are storing, and q arrow next is this, is equal to first. Okay, q arrow next is equal to first. What does it mean? What is the see, this is the node which we are creating for the first time. Okay, people are following? Is it the first node that we are creating? Now what is the value of first right now? What is the value of first right now? So just observe here, when we called insert front, okay, see, first is equal to null. If first is equal to null, we come here. What is the value of the first now? Null it is. Correct, right? So even this is also made as null. Correct?
Yes, sir.
So because this is the first node that we have created. So the previous field is also made as null, and the next field is also made as null. And next what we are doing, if first not equal to null, if first is not equal to null, so this is insert front. If I want to insert one more node, where I should be inserting it? Just before this, here, it comes here. When I write the new node here, one more, now this field cannot be null now. Correct, no? So if first arrow, first not equal to null, now what I do, first arrow previous is equal to q. Okay, so q will be pointing to the new node, and what I'm doing, I'm storing the address of new node here. Okay, and then return q. OP people understood?
Yes, sir.
Yeah, so this is one node. For one node we have done. Okay, let me make it little short. I'll take one more node and show you. Okay. Let me copy this itself. Hello, sir. Sir, really? ಏನು ಸರ್ ಹೇಳಿ ಸರ್. ಹಾಂ ಹಾಂ ಹೌದು ಸರ್, ಹಂಗೆ ಮಾಡಿದಾಗ ಆಗುತ್ತೆ ಸರ್. ಯಾಕಂದರೆ ಆ ವೈಟ್ ಬೋರ್ಡ್ ಇದಲ್ಲ, ಅದು ಆ ವೈಟ್ ಬೋರ್ಡ್ ಇಟ್ ಟೇಕ್ಸ್ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡಿ. ನೀವು ಈಗ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡಿರ್ತೀರಿ. ಎಸ್, ಸಾರಿ, I'll try to compress this. Okay, let me delete one or two fields. I think all are not necessary. Here also I'll delete two. Okay, see, now what we are doing here, so this is what I created first. Okay, so this previous field is also null, and let me make this as empty. Everything is empty. Okay, and the next field is also null. Okay, now here, now I want to insert one more node. So node is created. Now I'll assign some SSN to this, say 2, and then some department CSC, and then some okay, I have designation AP, and then so this is phone number, some number I'll write. Now I come here. Okay, so everything, all fields I've defined for the new node which is created, and who is pointing to this? For this we have first pointing. To this node we have first pointing, and to this node you have Q pointing. Okay, let me write here. Okay, it's difficult to write, but I'll tell you. So first is pointing to this, and Q is pointing to this. Now what we are doing here, Q arrow previous is equal to null. Okay, so because this is insert front what we are doing, so now this should be the first node, and when this becomes first node, what should be this field? It should be null. Q arrow previous is equal to null. Q is pointing to this, arrow previous is equal to null. We are storing null here. Correct, right? Hello?
Yes, sir.
Okay. Next you observe, Q arrow next is equal to first. First is pointing to this, and Q is pointing to this. Q arrow next is this field. What is that I need to store here? Address of this node. So how to do that? Q arrow next is equal to first. Now what comes here? Address of this node. Okay, let me take address of this node as, or I'll just put a pointer, arrow I'll put from here to here. Correct? So this is what, when you say Q arrow next is equal to first, so this address of this is stored here. And next, first not equal to null. Is first not equal to null? So because first is not null, it is pointing to this node right now. What you have to do now? See, you got to store address of this node here now. Instead of, you have to remove this null and put address of this node here. How to do that? So first arrow previous is equal to Q. Q is pointing to this, and first is pointing to this. Using first you access this field. First arrow previous, it is this field, is equal to Q. Now what gets stored for here? So here address of this node is stored. I'll write one more. Something like this. Correct, no? And then return Q. What we are returning is Q. Okay, come here. Q is returned. First is equal to Q. Now where will the first point now? So first is not pointing to this now. First comes and points to this. Okay, people understood?
Yes, sir.
Okay. So now
Yes, sir.
this is not a circular doubly linked list. It is just a linear doubly linked list. Understood, no? See, how do we make it as a circular doubly linked list? Instead of storing null in the last, next field of the last node, what we do? We usually store the address of the first node, and here if I store the address of the last node, then it becomes a circular singly linked list, so doubly linked list. Now what we are understanding is the normal doubly linked list. Understood? Yes or no?
Yes, sir.
Yes, sir.
Oh,
Yes,
okay.
sir.
Now insert, this is how the insert front works. So when option 1, when you're creating, so this is how it gets created. Okay, next. Now I think okay, this function is clear to all of you. Now we'll go to the second case. Yeah, so case 2 is again insert front. Okay, say for example the doubly linked list is already existing. Now I need to go for inserting to the front. Okay, and again I take the choice 2. So and read data, I call the function read data. Now what read data will do, it will read all these things, all the data it will read, and then immediately after that I make a call to insert front. So same function what we understood. Okay, so fi I am passing, and the return value also I am assigning it to fi. Insert front function, I think I need not explain it again because it's the same function, you have understood it. Next, so case 3, okay, inserting at the rear. Okay, so comes here again, before inserting read the data and then go for making a call to insert rear. Now we'll go to insert rear. So this is what insert rear is. So understand here, I'll try to modify this itself. So I think I'll copy this down. Let me take here. Okay, it's something like this. Now insert rear. Okay, I have to insert here. See now. So node q and current I am taking. Cur is equal to first. Okay, first is pointing to this. First is pointing to this. I make cur also to point to this. Current also to point to this. While current arrow next not equal to null. So current is equal to current arrow next. Okay. Now I make current increment and reach the last node. Okay. See, now when current is pointing to this, current arrow next not equal to null. Okay. Now we increment the current, comes here. Current is pointing to this, but first is still pointing to this itself. Now this current, okay. And again, when I go back to the while loop, current arrow next not equal to null, I check it is equal to null. It stops here. So OP people understood with this loop, correct? No? So when you initialize current to first, and when you run this loop, where will be the current pointing? Current will go and point to the last node. Is that clear?
Yes, sir.
Current is pointing to this and first is still pointing to this. And now time to allocate the memory for the new node. Let me copy this. Okay, here. Now what we do, so I've created the node, let me make them empty. Next, so assign all the fields SSN, then some department, and then some designation, and some phone number. Okay, next, observe now Q arrow. Now who will be pointing to this newly created node? The first is pointing to this, current is pointing to this, and who is pointing to this? Q. Q arrow next is equal to null because this is the last node. Okay, so you make this as null, this field as so make it as null. Okay, so the next field of the last node is made as null. And next what you are doing, see current arrow next is equal to Q. So current is pointing to this, and this node's next field is null right now. Now this should hold what? Address of this node. How to do that? Current arrow next is equal to Q. Is that clear? Is this statement clear?
Yes.
Okay.
Yes, sir.
Current arrow next is equal to Q. So that means you have a pointer from here to here. Pointer set from this to this. Next what you have to do, you have to store the address of this node here. Okay, how to do that? How to store the address of this node here? Who is pointing to this? Q arrow previous is equal to current. See, Q arrow previous is equal to current. What happens? Address of this node gets stored over here. Okay, that's all. So that is what is insert rear. And return what? First. So first is still pointing to this itself. Okay, so we first was pointing to this, we made current to point to this, and we keep incremented current until it reaches the last node. Once it reaches the last node, go for creating a new node, assign all the fields, and set its next field to null, and go for making current arrow next is equal to Q, and Q arrow previous is equal to current. Is that clear?
Yes, sir.
Okay, next, so we are done with insert rear also. Now case 4 we will understand. So case 4 is delete from front. Okay, so delete front. So case 4 delete front. So I'm passing the first. Okay, we'll go to delete front now. Yeah, delete front. So again I've taken one more temporary pointer with the name current, and then first I'm checking with if the list is empty, doubly linked list is empty, first is equal to null, can't delete, the list is empty, and return first. Otherwise if first is not null, okay, see, let us have a look. See, this I want to delete now. Now if I want to delete this, okay, what is that I have to do? See, before deleting this I need to make first point to this node, okay, and then I should go for deleting this. How to do that? First I have to take another pointer current. I want to make current to point to the same node to which first is pointing. So current and first will be pointing to this node. Now I've got an additional pointer current which is pointing to this node. Next first can be made to point to this. First is equal to first arrow, next first is pointing to this. Now using current you go for deleting this. Okay, is that clear?
Yes, sir.
Okay, same thing we do here. See, current is equal to first. So current is pointing to the first now. So there are two pointers pointing to the first node. One is current, another one is first. Next, what you have to do, so now since current is already pointing to the first, now first you increment it. First is equal to first arrow next. Now first points to the next node. Here we have the current pointing here and first pointing here. Now using current you go for deleting this. Where is it? Yeah, this one. And first arrow previous should be made as what? Null. So because this will become the first node now, so first arrow previous you make this as null and free current. And free current, make first arrow previous is equal to null and free current and return first. Is that clear? Yeah,
Yes, sir.
you
Yes, sir.
understood. Okay. Next, delete rare. See, if it is a circular doubly linked list, you don't require the additional pointer because we are using the additional pointer current here now. Okay. If it is a circular, if you make it a circular, only with one pointer you can do insert front, everything you can do it. Okay, now we'll go here to delete rare. Yeah, case 5 is delete rare, deleting from the rare end. Okay, so case 5 is delete rare. So I'm calling delete rare, and again what we are passing is the first pointer. So we'll go to the function delete rare now. Yeah, so again even in delete rare, okay, so again current is an additional pointer that is taken, and we make current also to point to the first node. And before deleting we check whether the doubly linked list is empty. Now how do we check that? First is equal to null. If first is pointing to null, it means so the list is empty and you cannot perform the delete operation. Next, what you have to do, if first arrow next is equal to null, okay, what does it mean? Yeah, can you tell what this case means now? If first arrow next is equal to null, what does it mean?
It's the last node.
So doubly linked
Single
list
node.
with only one node, correct, right? Now what you have to do, return first is equal to null. Okay, this is the only node which is present. Now return first is after you delete this, okay, after you delete this, now first will become what? Null. You have to make first as null. If it is not the single node, if there are multiple nodes present, more than one node present, what you have to do, you have to make current to point to the last node, because you got to delete the last node now. So while current arrow next not equal to null, okay, current is equal to current arrow next. Keep incrementing the current until the pointer current reaches the last node. Once it reaches the last node, see what you got to do. See, current will be pointing to this. Say for example I want to delete this, current is pointing to this. Now the last but one node, so this you have to make it as what? Null, because this you are going to delete and this should be made as null right now. How to do that? Current arrow, so current is already pointing to this, current arrow previous arrow next. So same thing what we are doing here. Current arrow previous arrow next is equal to null. Now using current which is current pointer which is pointing to the last node, I access this field. If I access this field, I get the address of this node. Now using the address of that node, I access what? The next field, and I assign null. Hope you understood this statement.
Yes, sir.
Is that clear? Okay. Now after setting the last but one node next field to null, so you go for freeing the current. Okay, free current. So the memory allocated, so this memory allocated current will be deallocated. Okay, and this is already set to null. And return first again. Return first. Now the last one is display. So display, again we are passing, so case 6 we are passing first, okay, and display will not return anything, okay, we have made it as white. Go to display now. Yeah, display, and you should also count the number of nodes while displaying. So count is equal to 0, and if first is equal to null, the list is empty. Otherwise, while first, okay, first is not null, I go for displaying all the details. So all this are separated by a tab space. Social security number of the employee, name of the employee, department of the employee, designation, all fields are printed. And once you print the details of the first node, so you make first to point to the next node. First is equal to first arrow, next, count plus plus, and you have the next data. Now how long you are going to do this? Until the first becomes what? Null. The moment the first becomes null, so you come out of the loop and say so many nodes are there, okay. And case 7 is exit, where we make done is equal to 1. We assign done is equal to 1 and then break. So in the while loop, since we are checking while not done, so this not of 1 will become 0, and it will make the loop to terminate, okay. So and the last part of this question is to demonstrate the DLL. DLL can be used as a double-ended queue, okay. Now you should go for performing insertion and deletion appropriately, because you have written the function for inserting at the front, deleting at the rear, deleting from the front and inserting from the front, everything, for everything you have written the function. So when you are asked to demonstrate the double-ended queue using the doubly linked list, you should go for appropriately inserting and deleting. So you should know how to call, when to call which function, okay. So that demonstrates, that we will demonstrate when we go for the execution. OP people understood till here? Any doubts in the program? So I think so this was not a difficult program for you people, because you had already understood how to do the same thing for a doubly linked list, circular doubly linked list with an header node. Did you face difficulty in understanding this?
No, sir.
Okay. So this is the program, and execution of this we will do it later after your second test, okay. So I'll execute this and I'll show you how to demonstrate the program for the double-ended queue, okay. Along with the tracing we will do it. So if you have any doubts, you can ask me with respect to this. Any doubts? See, we have maintained the uniformity across the programs for you to easily understand. So if you just look into the SLL and DLL, so there is uniformity. So because we have made use of the same function, malloc here also, same there also, and even the flow also, across the programs is maintained uniformly. So that you can easily understand. Okay, no doubts? Okay, if you don't have any queries, so then I'll move for taking the attendance.